Hey guys, Chris the Ultimate Recycler. Welcome back to my shed and the channel, and we have a repair job on the bench. But this week I've got my Ultimate Recycler t-shirt on because I need superpowers. I've got repair jobs to do. I've got obligations of unboxings from the storage shed, from the shop store. I want to get something else out of the carport, and I've had people drop off things for repairs lately that I've said, yeah, I'll do a video on that. And I've just got to get onto it. So let's go. This is a vacuum cleaner, a fairly modern one and quite an expensive one. It's a Zelmer Odyssey 1700 watt. It was dropped off a couple of days ago at the shop for e-waste because it's got a fault. Apparently it's been fixed once before and it's playing up again. Now I just checked them out online, and these are still a current, I think they're a current model, and they're over $400. So they're not a cheap item. I think it's worth trying to fix. There's the switch. I've just plugged it in and it seemed to work, as you heard then. However, it's got a speed control, and if you turn the speed control down a couple of notches, so it's still better than half speed, it stops. So we'll have a look at what's going on, and hopefully it's an easy fix and we can save it from going to e-waste. Now here's the speed control gauge here, and it's a faint texture mark at probably about 3/4 of the speed, and if we turn it on, it's just humming. I don't know if you can hear that. If we go up a little bit, the motor's still humming, and then it actually just starts to work. So it's not until you get to that 3/4 section that it starts to go. From there on, it seems okay. But there's got to be something going on with this. It shouldn't be like that. Let's pull it apart and have a look. All right, let's start by looking in this part, and this is where your bag is. Now, not only have we got the vacuum, but I've also got all the accessories and 2 or 3 boxes of new bags. So it's well worth getting going if we can. And I did have a quick look on eBay, and you can still buy all the filters for them. There's a little filter that goes across here. It's pretty clean. The motor actually looks excellently clean, so it may not have had a lot of work. It has a note here. You can just make out that pink sticker. It's got a date of 2018, so I guess that's when it was bought new. And I did notice underneath that it's got a green sticker that says Fit New Switch 2021, so that must have been the last repair. Now I've got to get into the thing, and any scrappers will know that vacuums are awfully difficult to get into. There's a lot of plastic, and it's not usually worth scrapping them out because all you've got is one little electric motor. Scrappers predominantly just pull the long cords out and scrap the cord and leave the rest. Let's pull a few screws out and see if we can get it apart. Wow, that was easy, but we've just dropped everything. There's the switch for the, oh, that retracts the cord. Okay, there's a little, I have got it unplugged. There's a little control for the variable speed. It possibly may just need a clean. There is a potentiometer there that we can adjust. But everything's very loose in here. Things just fell everywhere. There's the main power switch lever. Nothing seems to be screwed in here. It all seems to just float around and held together by the cases. Nothing unplugs, which doesn't help. Oh, that unplugs. That's the mains coming in. Okay, the main switch there seems to operate fine, so I don't think there's any issues there. We have power going out to a socket for the power head, which is an option for this. And then we have the wires going to the motor. Okay, I've just plugged it back in, and I was going to just carefully move the variable speed control to see what it would do, but I can't get it to start now. I've got the main switch here on, and nothing's happening. And if we check the mains voltage from the switch one end, the 2 wires come off the spool for the mains cord, and we have 240 volts, so we're good there. And the other side of the switch still shows our 240, so the switch is on and there's no problems with the switch, but the motor's not going. So don't know why. Oh, actually I know why. The variable control is probably a bit low. Let's turn it up a little bit carefully. There we go. So it's working, but it's only working in the top quarter of the treble. Now I don't know if that little potentiometer there can adjust that, or whether the actual slide control is faulty. I might just have a tweak of that pot and see if it'll make any difference. Now let's see if we can do that without touching anything we shouldn't. Screwdriver's too big. Okay, let's try a plastic alignment tool. Alright, turning that either way makes no difference at all. So I'll leave it back where it was, and if we move this up a bit it should still start up. There we go. So maybe this needs a clean, maybe the wipers aren't contacting inside. Might give out a bit of a spray with deoxit and see what it does. Okay, the unit's unplugged, so let's give it a good spray in here with the deoxit. It may have got a layer of dust over the carbon, so we'll give that a good workout. Alright, let's put the power back on. So nothing's happening there yet, but it is quite low now. Okay, that hasn't made any difference at all, so we'd have to presume that the control there's okay. I wonder what else could be causing that issue. Alright, I've just been testing some components on the board, and there's really not much on the board. A couple of capacitors, some resistors and a few diodes. The resistors check out fine, but the diodes appear to be all open circuit. Now, unless I'm testing them wrong, or I don't know, that's really weird, but I'm going to take this little board into my other workshop and perhaps check some solder joints as well. I can unsolder, actually I can unplug these wires, and I'll take this little section off here. There's a little MOSFET transistor there which we'll have to check out as well. There's not a lot involved, and I might as well test it. We obviously know the motor works fine. We know our main switch is working, so I'm guessing it's going to be either a bad joint or a bad component or something here, which is causing our lack of control. Now I think this panel can come off here off the side of the motor. And we can unplug that wire, yep. Oh, the whole motor's fallen out now. It's probably going to make things easier. Okay, that was a bit fiddly, but we've got all these bits out. Let's take them into the other room and test it all. Okay, so let's have a better look at this circuitry here. I've already learnt something, and one of the things I love about pulling things apart and trying to fix things that I don't know much about is it forces me to learn. So that isn't a MOSFET, it's a triac. And from a little bit of reading and watching a few videos, a triac is basically an in-circuit AC switch. So you have two terminals which allow the AC voltage to travel through, and it's turned on by a gate, which is a special signal voltage to turn it on. So it can handle much higher current than perhaps another smaller switch in a similar situation, and it can be controlled via the gate. That appears to test out fine. I've checked Google and I've tested the terminals, and it seems to be responding exactly how it should. Plus, given if that was either shorted or open circuit or something, our motor wouldn't work at all. So I'm confident that the triac's okay. So that leaves us with very few components really. The slider switch will test in a tick, or the slider control. I guess it's a variable resistor. This large box here is just basically a capacitor across the voltage to reduce interference on other appliances in your house. So the whole circuit would operate without that. And I have checked to make sure it's not a direct short. And again, if it was, our whole system wouldn't operate. So the resistors tested out fine. And there's another little one in there, and that's a little capacitor there. I'm not sure what that one does, but it appears not to be a short circuit, so that should be okay. Leaves us with 3 diodes. Now I did some testing before, and in circuit they appear to be open both directions, which to my understanding isn't right for a diode, but I'm not sure why all 3 are doing that. And if they are open circuit and not as they should be, why is this thing operating at all? So I don't know. We might unsolder some and see what's going on. Perhaps there is a dry solder joint here somewhere. But first of all, I want to check this control more accurately to make sure it is working through the full range of its movement. So we should have the meter in shot there. I'm on the 200k ohm range, and if I connect the terminals via these probes, try and get that on there. So there we have 22k ohms there, and if I run the slider down to this end, we go down to 0. So that must be flat out, which it was, that direction. And if we slide it back the other way, it gradually increases, and it appears to be operating perfectly fine right through the full range. And that's the other end. So it looks like it's probably a 100k ohm variable resistor. So that's smooth, precise, doesn't seem to be fluttering or anything, doesn't appear to be any bad spots. So I'm pretty sure that's okay. So that doesn't leave us with very much at all. I'm going to unsolder one of these diodes and maybe put it in my little component tester, or at least test it resistance wise once it's out of the circuit. Let's just try it again now that we've got good access. So we'll go the polarity one way, and it's open circuit. And if we swap the leads around, remembering a diode's basically a one-way valve or a one-way flow of electricity, and it seems to be open circuit the other way as well. So maybe we need a higher resistance scale. There we go. It works okay. We're on megohms there. And let's go back the other way. We've got a reading both directions. That's odd. I'm going to pull one out and see what it says on my little component tester. I was just trying these other two though, and even at the highest, I'm on 20 megohms on my meter, and I was just thinking that it's possible that the reading I was getting is from other components in the circuit because it's such a high impedance. But the other ones are still reading as open both ways. See the meter there? So both these two seem to have no response at all. Although this one does. Now it's marked DB3 underneath it. I don't know what that means. I'm assuming they're diodes. They look like diodes. So I'll try and work some numbers out of it and do a quick Google and see what Google tells me that it is. And I'll put it in my little component tester and see what that tells me. So this tells me it's a 76 picofarad capacitor. Well, that would explain why we have no continuity each way. Well, there you go. Looked like a diode to me, and it was marked D on the circuit. What's the go with that? Is it a diode that's not working properly that has turned into a capacitor? I guess if it's open circuit, because a capacitor doesn't have a direct connection, so an open circuit would have capacitance of some sort. I might check the number on through Google and see what that tells me. And if that's the case, if it is a diode that's no good, that might explain why we've got issues. Okay guys, it's the next morning and I've been doing some more fiddling, some more reading, some more watching of YouTube videos, and I've learnt heaps. It's amazing what you can learn from such a small little circuit. I've almost unpopulated the whole board in my quest to find out what's wrong. Turns out these things are diodes, but they're a special type of diode. They're known as a diac. And they are essentially another AC switch, a bit like the triac, but these ones are triggered by a certain voltage. Now the DB3 is the actual number of them, or the part number, and the 3 indicates 30 volts, which is approximately the voltage across them which is required before they switch on. So until it gets to that stage, they show as open circuit. So they're actually testing out fine. I haven't bothered to try and hook up a circuit to see if I can turn them on or not, but the fact that my little component tester registered them as a capacitor was kind of accurate, because there is no conductivity through them until they're switched on, either direction. They're not polarized like a normal diode. In fact, I think the circuit diagram that I saw for them is like two diodes in parallel, but in opposite directions. So from what I've worked out then, these are all okay. I removed the filter capacitor because when I tested it at one stage on the high impedance on my scale, it did show a resistance. And I thought, oh, maybe it's leaky, and maybe that's upsetting the voltage rails because it's absorbing some of the voltage. But then after removing it and testing it again, it was only showing some resistance on my meter because it was actually charging up. And once it actually charged, it then was basically open circuit, as a capacitor should be. So I'm learning lots. As I said, I'm ruling out parts that I thought may have been faulty that are now okay. So the only thing really left on the board, I could test all those capacitors very easily, all those resistors very easily, and they were fine. The only other thing was this little potentiometer or variable resistor, or a pot trimmer, and lo and behold, it appears to be open circuit through all the terminals. Now it's marked 100k, which I think is what our big long fader control was, 100k. This must work in conjunction with it, and it should be 100k ohms from one terminal to the other, and then the middle terminal that's adjustable should read the difference between one side to the other to actually add up to 100k's, as in you can vary the resistance on that middle pin. But all pins read as total open circuit, so that definitely has an issue. There's nothing more complicated about these variable resistors. They're normally like a carbon track, but it should have the 100k resistance across these two terminals, and it's open circuit. And if that works in conjunction with this one, that would explain why when the thing was in circuit and operating, we couldn't get anything to change by moving the trimmer. And maybe that trimmer is the adjustable control to get this one sort of synced in. So I'm guessing that that's why this was only half operating properly, because half of the variable resistance circuit was not working. So anyway, I'm totally convinced myself that that's the issue. I've ordered one online. In fact, I had to buy a box of 10, but they're remarkably cheap and free postage. So I can't do any more on this until we get the parts. But yeah, it's been an interesting journey of discovery. Back to this job now after a week of waiting for parts, and you can see my little bag of 100k trim pots has turned up. So now I have 9 of them in stock for future jobs. I will probably never use another one again, but they only cost $6, including free postage. A little bit different in size, but I don't think that will matter. And I did notice the N2 legs are fine. It's just the other end that's shorter. And if we have a look at the board, very nicely the designers allowed for the fact that we may have a shorter trim pot to install, because there's a couple of other holes there. So that should be easy to solder in. So I'll solder that in now. I'll set it about halfway, and we'll then put the circuitry back in the vacuum, hook up the triac to the motor again, connect up the mains wires, and as we did earlier in the video, I will try and adjust the trimmer to see if we can regain the use of half of this fader control. Okay, that's soldered back in nicely, and the good thing about removing and replacing all the parts is I can be fairly confident now that there's no dry solder joints. So we're all repopulated here pretty well. The pot looks good in there. I'll just set it, as I said, to halfway, and we'll wire this back up to the vacuum cleaner and have a play. So now the moment of truth. I've plugged it in, but the main switch isn't on there yet. I have dialed this control right down to 0. So I'll turn the switch on and see what happens. It's running. That's a good sign though. I think we need to adjust the trim pot. I had forgotten to adjust this trimmer, so it was a bit further round than halfway. Let's turn it right down and see what happens. Okay, we have no activity, which is a good sign. So we should be able to turn this trimmer up until it starts to work. Now we can just hear it buzzing there. So I guess that's how you calibrate it. So now that the motor's just starting to buzz and the main slide control is at 0, we should be able to increase the speed. That's fantastic. I won't turn it right up because there's nothing to hold the torque of the motor, as you saw. Seems to be working really well. Okay, I think I'll put the machine back together and we'll give it a test. Okay, the unit's all back together. It went together fine, no problems. I found it much easier to assemble it on its end because then everything sat in place and then the top cover just went over it. If I had dismantled it that way, I wouldn't have had bits go everywhere. Okay, let's turn it on. I did adjust the control so that minimum meant that it was actually working, but it's working at its slowest possible speed, which it's running now. I'm not sure if you can hear it. And we can accelerate beautifully right through the whole scale up until flat out. So that's working beautifully now. Excellent. I can rub that little black texture mark off there because we no longer need that as an indicator. So you know it's a good vacuum when the cord retracts all the way. There we go, all finished. Another job finished, guys. I don't know what was the most satisfying about this fix. The fact that I can make $50, $60, $70 selling a good second-hand vacuum cleaner, a good quality one, because I have all the kit and spare bags, or just the satisfaction of fixing something that other people thought was no good. Or maybe it was the fact that I've learnt a lot about electronics. I readily tell you guys that I'm no expert in hardly any fields, but that never stops me from having a go, and I do enjoy the journey of learning along the way. Probably the best thing is that I get to take it out of my shed, and the hoses and the other bits are in my van. They can all go in the shop, so that's very satisfying too. Thanks for watching. Another repair job done and dusted. I can now move on to something else. See you in the next video. Bye for now.